1.5 complex numbers. So, looking back at imaginary numbers, so non-real numbers. Remember, when we have a non-real number, we have the real part and then an imaginary part. So this is one non-real number. Here's another non-real number because of that I. However, when we have adding, subtracting with our I units, this is like a variable, so we can still combine like terms. So our real numbers can combine with our real numbers, and our imaginary numbers can combine with our imaginary numbers. So you don't need to have this one there, but you sure can if you wish to. Pause the video and do B, C, D. Remember, whenever there's a negative, you have to distribute. Do B, C, and D by yourself. You got 4 because 2i minus 2i is 0. Here you should get negative 5i. These two cancel. And here everything cancels. We just have 0. Now when we're multiplying, it's a little bit different. Now if I just have a number, I can multiply that in. So I'm going to have you save and do this one. I'm going to do B here. Foiling. Remember, each term here has to get multiplied by each term here. So first, outside, inside, last. So we do our first, we get 8. Outside, this becomes plus 6i. Inside, this is like a negative 1 times 4, and then I, and last. Negative 3i squared. This is where you have to be careful. When you have I squared, that becomes a real number. I squared is always going to be equal to, I'm going to combine these two like terms, so this becomes plus 2i. I squared becomes negative 1. So now this is a real number because negative 3 times negative 1, that's a positive 3 right there. So now I can combine these two real numbers, which will give me 11 plus 2i as my final answer. I want you to do A, C, D. Remember, for D, this is just doing this 2 times in a row. For the top one, you should get negative 8 plus 12i. Here we just got 13. And now, in the last one, we have 5 plus 12i. Conjugates. You should have heard this word before. Conjugates. It's a fun word to say, and it kind of was funny to write. Conjugates. So now when you look up here, what is a conjugate? A conjugate is when we have two binomials. So here 2 binomials, here 2 binomials. The terms are the same. So this is 3, this is 3, this is 2i, this is 2i. However, the sign, the adding, subtracting sign in the middle is opposite. The reason why we have these conjugates, because when we have a conjugate with imaginary numbers and actually radicals, roots, we should end up with a nice whole number, no imaginary left. So this is an example of a conjugate. This is another example of a conjugate. The negative 2 does not change because the first term and the last term, they stay where they are. It's the sign in between them is opposite. And the reason we need to know conjugates is because we have to simplify division problems, because this is not a proper way when we're dividing real numbers how to represent I. We want to make sure that we do not have any i's, any roots in the bottom of a fraction. The reason why is when we get into more complex numbers, we get to see if we can combine any like terms. So we have to multiply this by the conjugate of the denominator. So again, this number stays the same, this number stays the same. If this is subtraction, this is adding. So now what we have here is multiplying on both top and bottom. Often you will see me do this. And I first just multiply the top. So first, outside, inside, last. And then I multiply the bottom first, outside, inside, last. Now when I wrote this up before, I wrote out a whole new expression just simplifying here. I personally am not going to do that each time, and the reason why is just because it takes a lot of work. So what I do is I write this because I know that I squared is equal to negative 1. So right above it, I write this negative 1. I would write this negative 4 because subtraction's like negative and negative 1. So now I combine my like terms. So what I have here on top, I have this negative 6 because this becomes negative 6 and 8. Those are my real numbers, so I have a 2 there. 4 plus 12 is going to give me plus 16i. These two cancel. If these do not cancel, you did not pick the correct conjugate. And this right here, negative 4 times negative 1 is a positive 4, so 16 plus 4 is 20. You always have to simplify this fraction. You can either simplify by using the heart, or sometimes it's more visually appealing for people to write it out as in two separate fractions like so. And if you do that, this becomes 1/10 plus 4i over 5. That's my final answer. Pause the video and try to do B by yourself. You should have gotten this. So now we're going to be looking at different types of examples, two different things with standard form. So first thing, when you look at A and B, they're different. One is multiplying, one is subtracting. They're not the same format when dealing with these two. So this first one you have to be careful with because of those negatives. When we are multiplying, we can just simplify roots. We can just multiply across. However, because of these negatives, I'm going to rewrite this as I square root 3, because that's what I is the square root of negative 1 times I square root 12. Now I can multiply this across, and I get I squared, because I times I squared, square root of 36. And again, you should know your perfect squares. Square root of 36 is 6. The square root of I squared is negative 1. So right here, I would get negative 6. Now it's subtraction before we can do anything here. I'm going to simplify this root. I'm going to simplify this using perfect squares. You can, if you want to, still do your factor tree. So what I'm going to do is rewrite 48. 48 is 16. That's a perfect square times 3. So I'm actually going to rewrite this as square root of 16, square root of negative 1 because of that negative, and square root 3. And I'm going to write this as minus the square root of 9, because 9 times 3, square root of negative 1. I don't have to write that square root of negative 1. You could have written an I, just to kind of show you where all these numbers are coming from. Square root of 16 is 4. Square root of negative 1 is I. I cannot do anything with that square root 3. Square root of 9 is 3. Square root of negative 1 is I. And then I have the square root of 3. Because this right here is all the same. It has to be the exact same. That square root and I have to both be there. Now I can combine these two terms because it's saying there's 4 of them here and there's negative 3 of them here. So overall, it would be 4 take away 3, which is 1. You don't have to write the 1, but you sure can if your heart desires. That would be my final answer. And the last one, use the quadratic formula. Now, we did this in 1.4, so I'm going to pause the video and I want you to plug it into the quadratic formula and simplify your root as far as you possibly can. So this is what I've gotten so far. Again, you could use your factor tree to simplify this. I'm going to rewrite this as the square root of 4. So I've checked it already, square root of negative 1 and square root of 14. 14 can't break down into any other perfect squares. So I can simplify this now as 2 plus or minus, this becomes the square root of 4 is 2, square root of negative 1 is I, square root of 14 over 6. I can simplify this further. You can, if you want to, just look at your heart to simplify, or else you can simplify how we did up here and to write them as 2 separate ones. They're all divisible by 2. So my final answer would be 1 over 3 plus or minus I square root 14 over 3. I want you to pause the video and try to do B from start to finish by yourself. The answer should be negative 8 plus or minus I squared 23 over 8. Oh my gosh, look at that beautiful math. It's so beautiful. There you have it. 1.5, first section of the second part of the first chapter, done. Have a grand, have a wonderful day.